This is a group of lithium batteries used in new energy vehicles. If this set of batteries is short-circuited directly to the positive and negative poles, what will happen? It's risky. Let's go big. All right, let me take care of it. Let's do a short circuit test. This is an iron lithium 24-string nominal 72-volt lithium battery pack. What happens if we short it? We need to verify whether the BMS it is equipped with has a good short circuit protection feature. Not much to add. Let's go. Before starting the short circuit test, here's the battery info. The cell is a monolithic nominal 3.2-volt lithium iron phosphate cell. The internal resistance is about 0.7 milligrams, 24 strings together, about 16 milliohms. It's 80.2 volts. Each cell is about 3.34 volts. Okay? So theoretically, according to Ohm's law, voltage divided by internal resistance equals current. If we short it, the momentary short circuit current that can be triggered can reach 5,000 amps. Can iron lithium 24-string 72-volt 100 ampere board withstand the instantaneous short circuit current? Well, not sure. Let's dive into the results. In order to let everyone see the short circuit current better, let's get some gear. Got it. All set. Let me explain these tools. Between the tram's terminals, we set a switch. After closing the air switch, an oscilloscope will be used here. And with our front wheel meter, we can grasp how much the current can go at the moment of short circuit of lithium battery. Then this BMS will connect to our data cable. Check the battery board on PC. This BMS supports a continuous current of 100 amps. The short circuit current is about 10 times of the continuous current, so it should reach 1000 amps. Now let's look at the specific parameter information on the upper computer. Make sure to check the settings for short circuit protection. It's 1000 amps. The default short circuit delay is 320 microsecond. Just leave it. In addition, this interface is manufactured in production. We turned on the hardware for short circuit protection. Because this is an intelligent Bluetooth BMS, we have software protection logic. There is also hardware protection logic. Who's first? Who reaches the protection state first? Just open it. All set. Let's go. Let's see how large the current is. 3, 2, 1. Got it. Let's check the waveform now. Check it. The peak current is 740 amps because we just turned on the hardware accelerated short circuit protection on the upper computer. The protection will be triggered in advance during the current climbing process. It'll drop. Yep, safer now. Otherwise, we have to use the short circuit protection of AFA. Let's check it out on PC. Pass fault details. Is there a trigger protection for the MOSFET in the BMS? This one. Protection on. It's in off mode. Load removed. The MOS is back. It's on. It worked. This BMS has excellent short circuit protection features, but I still don't recommend you to do the short circuit test easily. The first, you may not know your battery. Especially for some batteries, the overall consistency is better. It's great battery. It's pretty big. When the corresponding internal resistance is very low, it'll pull more current. If the current rises quickly, the response time of the BMS has been exceeded. And if the current is too high, might hurt the BMS. This is very dangerous for the battery. Also, the short circuit itself is an irreversible injury to the battery pack. So for short circuit testing, we need to proceed more cautiously. If you really need to test short circuits, it is recommended to send the battery pack directly back to the BMS manufacturer. Have the manufacturer conduct a more rigorous short circuit test because it can adjust the corresponding protection parameters, or you can choose a higher current. In this way, the corresponding short circuit protection current will be larger. The chance of passing is pretty good, but there's a catch. The greater the current, the higher the price. So to sum it up, for the overall health status of the battery and for the overall safety considerations, do not test for a short circuit lightly. What other lithium battery tests would you like to see? Let me know.